Welcome back. All right. So we talked about the small stuff. Subatomic particles like protons, neutrons, electrons, which make up atoms. Atoms, a collection of atoms can be considered a molecule. Atoms and molecules make up the different minerals. So the issue is, though, everything in the universe is made up of atoms or molecules. So what makes a mineral a mineral? Let's find out. That's what the unit's all about, right? So there are 5 kind of components to be considered for something to be considered a mineral. You know, is this a mineral? Is this a mineral? You know, so what is a mineral defined as? Well, it's something that's naturally formed. It's a solid. It's inorganic, meaning it's composed of matter that didn't come from plants or animals. It has an ordered internal structure. That's something you cannot see. That is something you would need a very expensive microscope to even, scanning electron microscope to even begin to understand that. But that's something that happens internally. And it has a specific chemical composition, meaning it's made up of a certain thing. For instance, thinking back to the previous video, diamond, its chemical composition, its chemical formula is just C, carbon. So all diamond is just carbon. If it's not just carbon, then it's something else. It's not diamond. So these are the components it needs to be a mineral. Naturally formed, so not man-made. Solid, no liquid, no gas. Inorganic, didn't come from any type of living processes. Has some sort of ordered internal crystalline structure. You can't see that. And it has some specific chemical composition. So let's play America's fastest growing quiz sensation, mineral or not. Think about those 5 characteristics that I described. Of those, only focused on maybe the first few. Is it natural? Is it solid? And is it inorganic? The internal structure and chemical composition, that's something a little bit beyond what I need you to understand right here, right now. So let's just look at these things, understand a little bit about what they are, and just consider, are they naturally formed? Is it solid and inorganic? So the first one, ice. Ice. So let's walk through it. Can ice be naturally formed? Yeah, there's ice. Cold places of the planet. Is it solid? Yeah, that's solid. Is it inorganic, meaning it did not come from a living processes? Yep, there's nothing living about water. Guess what? Water, or ice, is a mineral. Excuse me, ice is a mineral. Natural, solid, inorganic. What about bones? Bones, right? You know, as a kid, you have to eat your vitamins and minerals so you can make strong bones, right? So, excuse me, are bones considered a mineral? Well, let's think about it. Natural? Yep. Solid? Yep. Are they inorganic? Well, no, they come from some living processes, right? Bones only are created by living things, living beings, so it is not a mineral. We need vitamins and minerals to make our bones strong, but bones themselves are not minerals. What about water? We talked about ice. What about water? This is the liquid form of water. Well, it fails. Something. Natural? Yeah. Inorganic? Correct. Water is not living. Solid? Oh, no. Falls short there. So water, liquid water, not a mineral. Frozen water, ice, is a mineral. Interesting. What about fossils? Fossils. It's a cool Stegosaurus fossil there. Okay, the answer is maybe. This is just a trick one I threw in there. There are different kinds of fossils. Some fossils are the actual preserved animal themselves, so this preserved spider in amber, which from both cases wouldn't necessarily be considered a mineral. The spider itself is organic, so it doesn't fit that. Amber is actually fossilized tree sap. So the amber itself is made from tree sap, trees, living thing. So also doesn't fit that inorganic. So neither this amber nor the spider would be considered a mineral. Here's another example of a fossil. This was a baby woolly mammoth that they pulled out of Russia a few years back. You can see the hair is still there. It was frozen basically in time. That's just kind of fun to look at. So obviously not a mineral. But this kind of spiral-shaped fossil is. Here's why. A lot of times, not always, but a lot of times with fossils, like the Stegosaurus fossil you see back there, when an organism dies, it gets buried somehow in sediment, dirt, it gets covered in tree sap, it gets frozen, so it gets covered with something. For instance, the Stegosaurus died, got covered with sediment and dirt. The Stegosaurus itself decayed away, left behind these open spaces. Material filled in that gap. That material that filled in that gap becomes the fossil. So, in a lot of times, what you're looking at isn't the actual animal itself or actual organism itself. These, they are. But this one over here, this little shell over here, this little seashell, what's interesting, you can actually see one over here as well. So when it decayed, it was filled in with a mineral called pyrite. So in this case, this fossil is a mineral because it's made of the mineral pyrite. Interesting. Anyway, that's just kind of a random one there. Okay, continuing on. What about coal? Coal, not charcoal. That's something completely different. Coal and charcoal are two different things. Coal, this is the stuff that you rip out of the ground. It's what's burnt to generate electricity. It's what they used to throw in the locomotive engines back in the day when they had steam engines and choo-choos and whatnot. Coal. Is it solid? Yeah, it's solid. Is it natural? Yeah, it forms naturally. Is it inorganic? No. Therefore, coal is not a mineral. Coal, actual coal, is formed from the dying of ancient plant material. As that material kind of fell on a forest floor or fell into like a body of water and sunk to the bottom of a little lake or pond, that organic material built up, got compressed over time, squeezed out the water, was altered to form coal. That's why coal burns. It's made of organic material. You need organic stuff to burn, for the most part. So coal is actually ancient fossilized plant material. So because of that, not a mineral. All right, what about quartz? What about quartz? Natural? Yeah, occurs naturally. Solid? Looks like it. Inorganic? Think back to the chemical composition of quartz. Previous section, we talked about it being a mineral in any case. So quartz, the most common mineral in the crust, the most common mineral. You find quartz a lot of different areas. It looks different. Sometimes it forms these crystals like this. Sometimes it's just kind of blobby quartz. Sometimes it's different colors, pink, purple, any number of different colors. But quartz is a mineral, the most common one at that. What about one more? How about steel? How about steel? Here's a hint. This person right here. It kind of fails that first test. Is steel natural? It is not. It's man-made. Steel doesn't come from the ground. Iron comes from the ground, which is a component of steel. There's other ingredients that you need to make steel, carbon, a few other things. So all of these ingredients on their own could possibly be minerals, but when you make steel, it is a man-made thing, so it is not a mineral. Now, so that's just a little thing to kind of wrap your brain around what a mineral is, because a mineral is different than a rock. More on that in a couple sections later on in this unit. So minerals and rocks are two different things, right? But long story short, mineral is going to be solid, natural, inorganic, has a specific chemical composition. For instance, quartz is always SiO2, one silicon, two oxygen atoms. That's quartz. So it has a specific chemical composition. And minerals have an ordered internal structure to the connection of all their atoms and molecules. That's not something you can see. But if you focus just on the first three, natural, solid, and inorganic, you can kind of ascertain whether or not something is a mineral or not. So let's go ahead and pause there. When we come back, we'll talk about different characteristics of minerals to help us identify different minerals. There's a number of different ways we can test and look at characteristics of minerals. You know, are they shiny? Are they dull? Are they heavy? A number of different things. Do they taste delicious? There's a number of different characteristics that will help us distinguish different minerals. So I'll see you back here in just a minute.